So now they want us to figure out the equation and the graph. This just keeps getting better. Okay. Originally they give us y equals x squared plus 3, which, and they're going to ask us to graph it. So right away, y equals x squared plus 3, you know from last chapter, means it's just a typical x squared graph, so over 1, up 1, over 2, up 4, you know, squared. Plus 3, which means it goes whoop, up 3. So I can just get right to graphing that, and I go 1, 2, 3, starts here, over 1, up 1, over 1, up 1, because 1 squared is 1, 2 squared is 4, so it's going to go over 2, up 4, over 2, up 4, and then I can draw my pretty little wink. We'll just pretend that's over there. Beauty. That's pretty much what x squared plus 3 looks like. So, what would the inverse look like? Well, now that we have the graph, you might think, well, that's easy, because all I have to do is flip it like that way over this line, which means that this point goes here, and these points go here, and these points go 1, 2, 3, 4 here. So it's, maybe we might put that a little farther out. So it's going to look like that. There. Flipped over the y equals x line. So it's actually easier to do it that way than to do what we're about to do. Dun, dun, dun. It's not that hard. Okay, so switching x and y. That's what inverse graphs are all about. You take x, you make it y. You take y, you make it x. So we're going to change this. We're going to make it x equals y squared plus 3. But if I grab my handy-dandy graphing calculator and I go to put that in, you can't, because it's just y equals.